Dear students, in this session, I'll be learning about the feedback amplifiers, types of feedback amplifiers, properties and advantages of negative feedback amplifiers, and comparison of the feedback amplifiers. From the module 2, that is BJT applications, feedback amplifiers, and oscillators. First, we focus on the feedback amplifiers. What is a feedback amplifier? You are aware of an amplifier. Amplifier is a device which strengthens the weak input signals. But the feedback amplifier which affects on the bandwidth amplification, impedance, input impedance as well as output impedance. We will see what is the feedback amplifier. The voltage at the current output is fed back to the input through a modifying network that determines the magnitude and the phase. Based upon the feedback energy phase with the input signal, we can classify the feedback amplifier into two types. One is a positive feedback, another is the negative feedback. In the positive feedback, so as we know, feedback amplifier means part of the output which is fed back to the input to improve the bandwidth, to improve the impedances, etc. In positive feedback, the feedback energy is in phase with the input signal. So positive feedback energy is in phase with the input signal. What is in phase? In phase means the phase of the feedback energy is in phase with the input signal, means the phase of the feedback energy and input signal are same, which means either 0 degree or 180 degrees at both input signal as well as the feedback signal. Positive feedback which increases the gain of the amplifier. This also increases distortion, noise and instability. So we are observing various disadvantages in the positive feedback. How to overcome those disadvantages? To overcome those disadvantages, so we can go for the negative feedback amplifier, so that the positive feedback can be used only in the oscillators. Positive feedback cannot be used for the amplification. So to overcome the disadvantages of the positive feedback, we can go for the negative feedback. So negative feedback, where the feedback energy is out of phase with the input signal, which means the phase of the feedback energy is 180 degree with respect to the input signal. This negative feedback which reduces the gain of the amplifier, which reduces the distortion, noise and instability. So because of these advantages, so negative feedback is employed in the amplification. This feedback increases the bandwidth. Negative feedback increases the bandwidth and also improves the input and output impedances. So due to these advantages, as I told you, negative feedback is frequently used in amplifiers. Dear students, here you are observing the two types of feedback circuits. One is positive feedback circuit, another is negative feedback circuit, where beta is the feedback factor. Here part of the output which is fed back to the input signal through the network called feedback network. So here the phase of the feedback signal is positive or in phase with the input signal in case of the positive feedback. Hence this is used only in the oscillators. Second, in the negative feedback. In negative feedback, the phase of the output signal is 180 degree with respect to the input signal. You are observing the signal, the feedback signal and the input signal, which are completely inverted with each other, which shows that there is a phase shift of 180 degree between the feedback signal and the input signal. So this is once again the negative feedback and the positive feedback. You are observing input signal is shown here. So when this input signal passes through the amplifier, where the phase shift is 180 degree, which gives the output which is 180 degree phase shift with respect to the input signal, and part of this output signal which is fed back through the feedback network. Then what is that the feedback signal which is in phase with the output signal, because this is 0 degree phase shift between output signal and the feedback signal. And this the feedback signal, the phase of the feedback signal is 180 degree with respect to the input signal, means this type of feedback is called as a negative feedback. And moving on to the next circuit, so what you're observing there is that when the input is applied to the amplifier, the output of the amplifier is the inverted, means 180 degree phase shift with respect to the input signal. Suppose that 180 degree phase shift signal is fed back to the part of that fed back to the inputs through 180 degree phase shifter. So what will you get? We will get the inverted phase, the feedback signal as an inverted phase with respect to the part of the output signal. Then that is in phase with the input signal, which shows that the feedback signal is in phase with the input signal. Then that type of feedback is positive feedback, which is usually employed in the oscillators. Properties of the negative feedback amplifiers. First property is this desensitize the gain, means the negative feedback amplifier is less sensitive to all kind of variations. Second one is reduce non-linear distortions. So how the negative feedback reduces this non-linear distortion? So here output is proportional to the input. Negative feedback amplifier makes the output which is proportional to input, thereby reducing the non-linear distortions. Third is reduce the effect of noise. This negative feedback also reduce the effect of noise, means which minimizes the unwanted contribution of the electric signals, and this noise may be generated by the circuit components or by external interference like lighting and sounds. Third property is that control the input and output impedances. It increases or decreases the input and output impedances. This is done by choosing the appropriate feedback topology. The last property is that which extends the bandwidth of the amplifier. This means the bandwidth of the negative feedback amplifier is increased. Next topic is advantages of negative feedback. We have the 6 advantages which is based upon the properties of the negative feedback amplifier. First one is gain stability, and second one is significance of the bandwidth, significant extension of bandwidth, means bandwidth can be increased. Third is very less distortions, so which is less exposure to the interferences. The fourth one is a decreased output resistance. Fifth advantage is the stable operating point. And the sixth advantage is that which reduces the noise and other interferences in the amplifier. Comparison between the positive and negative feedback amplifier. Negative feedback energy is out of phase with respect to the input signal, which means 180 degree phase shift between the input signal and the feedback signal. But in positive feedback, the feedback energy is in phase with the input signal. Second difference, in negative feedback, gain of the amplifier decreases. In positive feedback, gain of the amplifier increases. And third difference, in negative feedback, gain stability increases, but gain stability decreases in positive feedback. Fourth, noise and distortion decreases in negative feedback. Noise and distortion increases in the positive feedback. And in negative feedback, bandwidth can be increased. In the positive feedback, bandwidth can be decreased. And final application, the negative feedback can be used in amplifiers, positive feedback can be used in the oscillators. Next is types of feedback. Based upon the mixing and the sampling employed, the feedback amplifiers can be classified into 4 types. Voltage series feedback amplifier, current series feedback amplifier, current shunt feedback amplifier, voltage shunt feedback amplifier. So which means the first case, voltage series feedback amplifier, it is series mixing and output voltage sampled, like that in current series, current shunt and voltage shunt also. In voltage shunt feedback amplifier, so it is the mixing is of shunt type, and here output voltage is sampled. So out of 4 types of feedback amplifiers, Only voltage series feedback amplifier you will be studying in this according to the syllabus. So we'll focus now. We can focus on voltage series feedback amplifier. We are observing voltage series feedback amplifier where the mixing is in series and the output voltage is sampled here. So refer to the figure. So gain of the amplifier is represented as A, and the gain of the amplifier is the ratio of the output voltage to the input voltage. The feedback network extracts a voltage Vf is equal to beta times of V0, where beta is the feedback factor from the output V0 of the amplifier. When V high, Vi is equal to Vin minus beta V0. Vin is limit Vs. So therefore Vi is equal to either Vin minus beta into V0 or Vs minus beta into V0. Both are same. Then V0 is equal to A into Vi is equal to A into Vin minus A into beta into V0. Take minus A beta V0 onto the left hand side. We will get V0 of 1 plus A beta is equal to A into Vin. Then V0 by Vn is equal to A divided by 1 plus A beta, where V0 by Vn is nothing but AF, that means the feedback gain. So finally, by reorganizing, we will get AF is equal to A by 1 plus A beta. So negative, the input impedance with the feedback ZIF is equal to Zi into 1 plus A beta, which increases. The output impedance decreases with the feedback, that is ZOF is equal to Z0 divided by 1 plus A beta. The product of A beta is much greater than unity. Therefore, 1 plus A beta is equivalent to A beta. Therefore, the feedback gain AF is equal to gain divided by A into beta. A and A get cancelled. 1 by beta remains over there. It may be seen that the gain now depends only upon the feedback fraction beta. The feedback circuit usually the resistive network. Gain and bandwidth of the feedback amplifier. Dear students, you are observing in the characteristics of a frequency versus the amplification in decibels. In case of RC coupled amplifier, gain reduces at low frequency as well as high frequency ends. So A beta is no longer much more than the unity. As a result, the percentage reduction in the gain is less at the two frequency ends compared to the mid frequency band. That is, F1 is too much less than F2. You are observing the from the characteristics, it is observed that F1 means the lower cutoff frequency is too much lesser than the F2, and F means the frequency 1 of the feedback with feedback is too much less than the higher frequency or upper cutoff frequency with feedback. So this shows that bandwidth is equal to F2. Bandwidth of an amplifier is F2. Bandwidth with feedback is equal to F2 into F, because F1 into F is too much less than F2 F. This can be shown that AO into F2 means what? Gain bandwidth product. The product of the gain without feedback is equal to gain bandwidth product with feedback. Gain stability with feedback. Here the overall gain with negative feedback is given by AF is equal to A divided 1 plus A beta. This is the feedback gain for the negative feedback amplifier. So differentiating on both sides, what will you get? We will get DAF by AF is equal to DA by A into 1 divided by 1 plus A beta as a constant. DAF by AF is equal to DA by A into 1 divided by A beta, where A beta is too far greater than 1. This shows that relative change dA by A in the basic amplifier gain is reduced by the factor A into beta in the relative change DAF by AF in the overall gain of the feedback amplifier. Thanks for watching this video.